The ally for this lesson is to be able to use integration to solve kinematic problems. Now, 2 lessons ago, we looked at how we can use differentiation. So we said, if you've got a formula for displacement, so if I've got displacement as a function of time, I want to get the velocity as a function of time, then what I need to do is I differentiate. So I differentiate the displacement and it will give me the velocity. And that kind of made sense to us because the velocity is the gradient of displacement time graph. So therefore, differentiating, finding the gradient, so that's how we get from displacement to velocity. And similarly, the same to get from velocity to acceleration. So from velocity to acceleration, I will also differentiate. Now we know that in the process of differentiating is integrating. So to work backwards, I can go from acceleration to velocity, I can integrate. And to go from velocity to displacement, I can also integrate. And this actually makes sense because when we've got a velocity time graph, the area under the graph is the displacement. And when we're integrating, we're finding the area under the curve. So differentiating to go from displacement to velocity or velocity to acceleration, integrating to go from acceleration to velocity or velocity to displacement. Let's have a look at example 6. A particle is moving on the x-axis. At time t equals 0, it is at the point x is equal to 5. The velocity of the particle at time t seconds, where t is greater than or equal to 0, is 6t minus t squared. So I've been told the velocity is 6t minus t squared. And part A, I want to find an expression for the displacement of the particle. Well, I know I've got the velocity, I want the displacement, so I need to integrate. So I'm just going to say the displacement is equal to the integral of the velocity with respect to time. If I integrate 6t, I get 3t squared, so I've increased by 1 and divided by the power. Here I'm going to get minus 1/3 t cubed. Now don't forget, we're integrating, we're going to need a plus c on the end. And it caused me some problems, because clearly I'm not at my final answer yet, because I've still got a plus c. But I know that when t equals 0, the particle was the point x equals 5. So the displacement was equal to 5. So when t equals 0, s is equal to 5. That means that if I sub in here, t is equal to 0, and I sub in s is equal to 5, 5 is equal to, well, 3t squared is now just 0, minus 1/3 t cubed is also 0, plus c. And clearly I've shown that c is equal to 5. So let's just write our equation then for displacement nice and neatly. S is equal to 3t squared minus 1/3 t cubed plus 5, because c is to 5. And so that's my expression for the displacement. Now B says, find the distance of particle from its starting point when t equals 6. Well, if I find the displacement at t equals 6, I'm saying t is equal to 6, I've got 3 times 6 squared, 3 times squared, minus 1/3, 6 cubed, plus 5. So you can see your calculator, obviously, and see what you get as your final answer there. So let me put that one in. Times 6 squared minus 1/3 6 cubed plus 5 is equal to 41. So I know that time t equals it. My displacement, or the displacement of the particle from O, is 41. But don't forget that at the starting point I was at 5, I was x equals 5. So I've gone from x equals 5 to x equals 41. So the distance starting point is just gone from 5 to 41. So it's gone 36. So distance from start point is, well, 41 take away 5. So it's 36 meters is the distance from the start point. Okay, and then example 7. A particle travels in a straight line. After t seconds, its velocity is by 5 minus 3t squared. And find the distance travelled by the particle in a third second of its motion. So I'm just going to start out with velocity equal to 5 minus 3t squared. And I need to say, well, the displacement is equal to the integral of velocity with respect to time. So what I do is I'm going to integrate that equation that I for my velocity with respect. So I've got, well, the 5 go to 5t, and then get 3t squared will go to plus 3t, is that right? No, not negative. No, it's still be negative, but 3t cubed, because I divided by 3, sorry about that. Now, the key here is in the third second of its motion. In the third second, that's between second 2 and second 3. Remember, the first second 0 to 1, then the second is second 1 to 2, and then the third second is second 2 to 3. So I need to integrate between those lines because I'm only interested in the distance travelled in the third second. So what I'm doing is I'm integrating, but between t is equal to 3 and t is equal to 2. But if I sub 3, I've got 5 lots of 3, take away 3 cubed, that's going to be 15, take away 27, so negative 12. Then I've got 5 lots of 2, take away 2 cubed, so that's 10, take away 8, that's 2. So I'm taking away 2 because I'm finding this. And therefore I get negative 14. So negative 14 metres is displacement, but they're only asking for distance, so distance travelled is 14 metres, and that in the third second travels 14 metres. Okay, having done those two, you should be able to now have a go at exercise 11D.